Hey everybody, this is Larry. This is day 1 of the April Leetcode Daily Challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this problem. Today I had a normal day. I went to the gym, but I was trying to do squats, but I hurt my groin doing, and not even that heavy, but just having one of those weird days. So I'm going to try to rest a little bit and try to figure things out, and that's it. We'll keep today's update short. And if you're new to the channel, for the new month, it's Larry. I usually try to give an update about my workouts because I'm training for the marathon later this year, and I want to give people, like you're struggling with Leetcode, perhaps, maybe not, hopefully not. I'm telling you what I'm struggling with, and hopefully their ideas, kind of come together, and I just kind of talk about it. Yeah. Anyway, let's take a look at today's problem. I'm going to keep the intro short today. We have 2140 solve questions with Brainpower. You're given a serial index 2D integer array questions, where questions of I is equal to points of I, Brainpower of I. The array describes the question of an exam where you have to process the question in order, starting from question 0, and make a decision whether to solve or skip each question. Solving question I will give you will give you points sub I points, but you're unable to solve each of the next Brainpower sub I questions. If you skip question I, you get to make the decision on the next question. Okay. Yeah. I feel like this is relatively straightforward dynamic programming. Even if you watch enough of my other videos, I kind of been coined some of these things. What do I call it? I call this like techno-tech, right? Meaning, you sometimes it's take an action, it depends on the context, but then you kind of just, in a way, write a brute force kind of thing, right? But yeah, so I think without further ado, we can think about it, right? It's just that, so if you take a point, what happened, right? Well, if you take a question and solve a question, get a point, what happens? Well, now you get to skip the next I, right? So that's really, so that's really it. Right? Yeah, I think that's really it, and that's dynamic programming. So let's get started, right? So let's say we have something like this, right? So we said n is equal to the number of questions, and then for okay, maybe I'll write it this way. Okay, so what do we want to do? Well, I forgot to write. Let's actually define dp is equal to just like a new array of length n or n plus 1. I think n plus 1 would be fine, though there's a little bit awkwardness depending on how we want to write it. But yeah, and then yeah, dp of 0 is equal to 0, right? Okay, and then now we say, okay, so here now we do a take no take thing. So now we're processing questions of I, right? So we're processing questions of I, and then we can just write something like, so again, this is going to be take no take, right? And like I said, there are a couple of ways you can write this, especially for this particular problem, because actually, no, let me take that back. I think one thing that you can make a mistake on is that for a lot of problems, for a lot of dynamic programming problems, there is this, maybe it's not quite an explicit idea, but that's why I want to be clear about it. Is this concept of symmetry, right? It's not really something that people explicitly think about, and honestly, for me, as even a competitive programmer back in the day, which is not a phrase that I would have said back in the day, it's not. It wasn't clear to me until I solved a lot more dynamic programming problems. Like probably the first, I don't know, 1,000, I probably didn't even realize I was doing it. But it's just, and I knew that I was struggling with certain types of dynamic programming problem, and I couldn't really figure out why. And the reason is, it turns out or of course there are other reasons why, but one of the reasons that I realized over time was that this idea of symmetry. And what do I mean by that? What I mean by that is that for certain dynamic programming problems, going from left to right is different from going right to left, right? And for a problem that has this dynamic programming symmetry, you can go left to right and right to left, and it'll give you the right answer, right? One example, which is not quite dynamic programming, but it's easy to say, but one example of this is like the shortest path problem, right? If you have the shortest path going from here to there, and the same cost function going from there back, then it doesn't matter which way you do, right? Like we do a breadth first search out or something like that, right? And you can think about breadth first search sometimes as a dynamic programming, depending on how it's structured. But so in that sense, you don't have to be careful. You could just do it and it'll be right because it's symmetric, right? However, it is way, sometimes it happens where there's no symmetry, right? Meaning, and this one is one of those, at least not if you have to be really careful. And the reason is because you get to skip the next what they call it Brainpower, but you skip the next X cells, right? But because you're skipping the next X cells, that means that if you're going the other way back, you don't know how many you're skipping at a current cell. I mean, yes, you can definitely construct the edges. You can make some of these implicit edges explicit, but you have to kind of do it, right? And actually, let me take a pause for a second and draw it out for you. I think this is a concept that this problem is actually a very good problem to kind of visualize it on. Is that, okay, so let's say, and one thing that I would also say is that very often we index things as if we're processing a current index or something like that for dynamic programming. But the way that I've been thinking about it more and more is that you have to be careful, and that what you want is actually not that. What you want is kind of the space between the numbers, right? For example, you have problem 1, right? Which is, I'm just looking at the example. So you have it's worth 3 points. I mean, the points don't really matter, but so it's worth 3 points, and you skip 2, right? And then you have problem 2, which is 4 3. So we say score and maybe I was gonna say P for points, but it's also confusing, right? Fine, just write points and then skip, right? So here we have P3, right? We have 4 4, and then P4 you have 2 5, right? And sure, you can maybe write something that is like, okay, so we kind of draw edges that way, but the way that I actually like to visualize it is, like I said, the space in between the things, right? And which visualizes a dot, which is a node, right? And what I mean here is that now, instead of thinking about it in this way, with the nodes here like this, we can just draw the edges, right? So then we draw them out kind of like this, from 0, which contains nothing, and then there's goes to here because it skips 2, right? Actually, maybe I drew that wrong. Skip each question. Unable to solve the next. So it's not okay. Maybe I said it because skip is actually a different thing, so maybe I'm kind of confusing things. But you're unable to solve each of the next 2 problems. So actually, I drew it wrong because you cannot solve the next 2, right? So maybe it goes to here. Actually, no. This is that I confused myself a little bit as well. Actually, yeah, no, this is fine because. Why is my drawing thing weird? Okay. Yeah, so starting at 0, and this is at, now your index 1, if you want to call it that, will be associated with this point, right? Maybe? No, the other way, right? So then here 2, meaning that you get to skip 2 problems, right? So here it goes to here because this point is associated with this and so forth, right? And here you may skip 3, right? And here you may skip 4, which maybe you just point it all the way at the end, and so forth. And so now you have this kind of graph, right? But now that you see this graph, you can see that my point here is still that you can go from left to right. I mean, you could just set this up very easily, right? Or visually very directly. But however, the thing about what makes problems like this tricky sometimes and easy to miss is that you cannot go backwards, or not easily. Like you see the edge, and maybe you see all these edges, right? Sorry, changing colors. You see these edges, and you know, maybe you can pre-process it in such a way that you draw them backwards, but that requires pre-processing of the data, right? So that means that, like, it's fine, it's okay, but you cannot just take the input, and if you do try to do it the other way, you're going to run into a lot of random weird struggles. And that's kind of the point that I have for this one. Yeah. Alright. So back to problem, take no text. So that now we go, okay. Right, so, oh yeah, actually yeah, it's fine. Right, so then now we no take, we get up. So there are two things you can do as well. Sometimes people call it push pull, dynamic programming. But the way that I want to do is just I update the next node, right? Like almost in the shortest path kind of way. I'm at node 0. Let's update all the edges going out. And for this problem, there's only one edge going out anyway. Well, one direct edge, but there's also a smaller edge that is one distance away because you're skipping one problem, right? If you skip this problem and don't do it, then it just goes to the next edge. So that's basically the idea. So then now you have take, no take. Let's separate them out, right? So if you take this problem, what happens, right? So then now, what is it? Question sub I of 1, right? So that's the, what's it called? That's the Brainpower. That's called, let's label it. Brainpower is equal to this, right? Then dp of I, I plus Brainpower is equal to, is it max? Yeah, max, right? So max, sorry, I'm still having some allergies, so I'm like pausing a lot because I have trouble breathing because I'm talking at the same time. Okay, yeah, max of dp sub I plus Brainpower, or dp sub I plus what's it called? Points sub, well, yeah, I would just write points and then when that points is equal to question sub 0, right? Something like this. And of course, if we don't take, then we just skip, right? And what does skip look like? Well, we just update the next one to just whatever we have now, right? No points, we just skip, and that's it. Conceptually, this is it. The only other thing that we have to, right, is that, well, I plus Brainpower could go greater than n, so maybe we just need to kind of go, yeah, maybe take index, I don't know, is equal to I plus Brainpower, but we want to min this by n, right? So that means that we're going all the way to the next step, and yeah. That means that if we go past n, then we just set it to n. That's basically it. And then now we can just return dp of n, and we should be happy, hopefully. Is it math.min? I always forget. Don't know how to do programming things anymore. Well, definitely should not return no. But oh, I see. Wait, what? Oh, this is a long way to just not tell me which way it is. Oh, line 41. I don't know. We don't have a line 41. Do I have to initialize the array? Oops. Okay. So that was it, I suppose. We don't need this. Okay. But apparently it is wrong. What am I doing wrong? Dun dun dun. Output 7. Okay, 2. Oh, it's bring. I said this, but yeah, it's Brainpower +1. Or this is this +1. I kind of, because you have to because you have to solve the current problem and then you skip the next one after that. So I actually, my drawing was wrong because I kind of forgot that you have to solve the problem and then skip the whatever after that. But as you can see, easy fix, right? Yeah, let's give it a quick submit. And there you go. Pretty okay, right? Yeah, so there are two things we can kind of maybe yeah. So what's the complexity here, right? Was I was gonna say, and it's gonna be linear time, linear space, right? This is linear space, linear time, just for the for loop, and then a second time also a for loop. Pretty straightforward. So everything is pretty straightforward for linear time, linear space in terms of, not that this is easy, just that that's a very easy and not the analysis is easy, right? And that's pretty much it. Yeah, that's all I have with this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.